Hello, everyone. Before we start our program, allow me to read again our Zoom etiquette so that the orientation will run as smoothly as possible. So first, please mute your microphone if someone is discussing and asking questions. Only unmute your microphone if you want to ask a question during the open forum. Second, Zoom has a special feature of annotation where you are able to write on the screen. Please avoid annotation as much as possible. And lastly, listen carefully so that after the discussion, you will be able to understand and engage with the speakers. Kindly ready yourselves and prepare to settle down. We will start in a few minutes. Thank you. Everyone, please pay respect for our Philippine national anthem. Excuse me, everyone. I'm very sorry for the trouble. We are having some technical difficulties. Good afternoon, everyone. Good afternoon to our speakers, students, viewers, and organizers. I am Ana Loisa Belido, and I will be your host for today's webinar. So to formally start our program, let us welcome our webinar head coordinator, Ms. Jeremiah Kizea-Bulmori, for her opening remarks.
Hello. So to our speaker engineer Mark Gallas, to our professor Kim Bundok, the whole grade 12 season, and to our viewers in our Facebook Live, good afternoon. We are all gathered virtually today for our first webinar of UPHSC DRRR webinar series, Hydrometeorological Hazards. This is part of our disaster readiness and risk reduction course, where we are tasked to conduct a series of webinars to campaign for be aware, plan ahead, and stay alert. Welcome to this webinar, and I thank you for fully participating. Let us take this wonderful opportunity to be informed, listen, learn, and ask questions if you have. Once again, thank you and good afternoon.
Thank you for those wonderful remarks, Ms. Jeremiah. And now, let us proceed to our webinar proper. So, our guest speaker for today is a weather observer from PAG-ASA Mactan. Allow me to welcome Engineer Mark Gallas.
Good afternoon, everyone. Wait, let me share my screen. I can't share my screen. It says host disabled participant screen sharing. Can anyone help me with this?
Try na daw, sir.
Kaya, try na ko. Ano na, okay na. Balik muna ni. Yan. Kita ng one PowerPoint presentation. Hello?
Affirmative, sir.
Okay. Let's start. Good afternoon, Sir Kim. Good afternoon, everyone. So we're here to discuss about the basic concepts of weather, hydrometeorological hazards, preparedness, and risk reduction. So I am Mark Galles from Visayas PAG-ASA Regional Services Division. So our office is located here in Airport Road, Pasok, Lapu-Lapu City. So here's the outline of this webinar. We'll be discussing about a short background about PAG-ASA. Next is about the basics about weather and climate. Then we will be discussing hydrometeorological hazards. Then the public weather forecast, or the PAG-ASA's product, like the public weather forecast and warning system. So to start with, PAG-ASA, Philippine Atmospheric, Geophysical, and Astronomical Services Administration, or PAG-ASA of the Philippines, is the national meteorological and hydrological services of the Philippines. So we are the authoritative that provides warning to the public. So we provide warnings for public safety regarding hydrometeorological hazards. So PAG-ASA, Philippines through PAG-ASA is a member of WMO, or the World Meteorological Organization. So it's a specialized body of United Nations who deals with meteorological hazards and other stuff related to the atmosphere. So PAG-ASA's mission is to protect lives and properties through timely, accurate, and reliable weather-related information and services. So let's proceed now with the basics of weather and climate. So let's define first this two terms. So first, weather is basically the way atmosphere is behaving, or it's the condition of the atmosphere over a short period of time. So meaning short periods, maybe around hours or days, or less than a month, something like that. So conditions at one particular time and place, including temperature, rainfall, winds, and so on. So later we'll be discussing meteorological elements or parameters that uh, that is being observed to to define weather or climate. So this can change very rapidly from day to day. So for example, this one, so the weather on Sunday is sunny and on Monday it's cloudy. Then the next day is sunny again. So that is weather. So weather is what you get on that certain period of time, on that short period of time. So next we have climate. Climate is how the atmosphere behaves over relatively long periods of time. So this definitely uh, somewhat we define it as the average weather of a certain long period, let's say months or years. So something like that. It's influenced by slow changes in the ocean, land, orbit of the Earth, sun, and energy output of the sun. So usually referred as the climate normals. So average values of different parameters such as rainfall, temperature, and so on for the last at least 30 years. So normally, if you will get climatological normals, so you need at least 30 years of data. So climate is what you expect. For example, we are expecting that on during May or April, May, we'll be facing a hot season, dry hot season. So that is an example of climate. To summarize, weather is the short-term state of the atmosphere. So that's just changes of the state of the atmosphere within days, while climate is the long-term pattern of weather. So let's say months or years. So this is the average weather over many years in one specific place. So here in the Philippines, our climate is defined as humid, equatorial, or tropical maritime. So this is characterized as high temperature since we are uh, at the tropics, and also um, high humidity since we are bonded by warm waters, and Philippines is an archipelago, and with this um, high temp and high humidity, we'll be expecting abundant rainfall all throughout the year compared to other regions at the, let's say, mid latitudes or in some parts of US or Canada, something like that. So aside from that, Philippines is also correct. The climate of the country has four types. So not all parts has the same climate. So you have four types. So mainly first, the type 1. This has two pronounced season. Dry. The dry season. This one at this first date at the I think first from November to April. So you could see the amount of rainfall is just below 100 mm for those months. So the next climate type is the climate type 2. These are regions or places located at the east side of the country. So this one, these regions don't have no dry season with a very pronounced maximum rainfall during the month of November, November to somewhere January. So that's a very pronounced rainfall there. But all throughout the year, they'll be experiencing rainfall compared to the climate type 1, is which has a well-defined dry season and a well-defined rainy season. So next we have the climate type 3. This is where the Cebu province belong. So here, season is not very pronounced. Relatively dry. There's a relative dry, so not so dry, and a not so wet compared to climate type 1. So Cebu belongs to this region, to this climate type 3. And lastly, we have the climate type 4. So the rainfall is evenly distributed all throughout the year. So as you notice, the climate types is defined on the rainy season. So again, in the Philippines, we do not have summer or winter. We only have 2 seasons. We have the dry season and the wet season. So normally, when PAG-ASA declares rainy season, they're referring only to climate type 1. So sometimes if you are on other places, like for example, you're at the climate type 4, you question sometimes that why is it that wala kayo ulan on those periods. Kasi nag-declare na si PAG-ASA og rainy seasons. So that means that the PAG-ASA uses the type 1 climate, this one, for the onset of the rainy season. So remember that, guys. So we have 4 types of climates across the country. So again, we'll discuss the basic of weather. So weather will not occur if these 2 things did not happen. There's no sun, no sunshine, not shining, and if the earth is not curved. So if those 2 stuff does not occur, then wala tay weather. So how does the curvature the earth affects weather? So different latitudes. So anay tay tropics, natay mid latitude. So diri to na-locate yung mga bugnaw na lugar. So different latitudes receive different sun angles. So as you notice here, for example kani sa tropics where Philippines is located, so direct kayo ang adlaw sa ato. So we are experiencing more sunlight, concentrated ang sunlight sa atong lugar. Unlike on these regions, for example Canada, so mas bugnaw dito, mas scattered ang light. So mas bugnaw siya compared to the tropics. So naay unbalance sa energy, which then makakos sa movement of air mass or the wind, and so on. So this one, another illustration. So kita na to diri na sa equator, mas kuan gid ang adlaw, mas concentrated compared diri sa mid latitude. This one is what we call mid latitude and the polar region. So this one, you notice here, so mo ni atong tropics no diri dapit. You notice natay mga bagyo. So these are low pressure area kani mga lingin-lingin diri, kaning gimarkahan natong pangalan. So at the mid latitudes, we can also see high pressure. So kung ato po natin ma-zoom unta, ato makita na diri dapit is init. Inato makita magud kagmay kaayo. So this is what we call surface map. So this is also a product of PAG-ASA. This is mainly used by forecasters to analyze data that are gathered. So if you notice at higher latitude, itong mga medyo padung North Pole na natay mga high pressure areas. And mostly diri sa tropics, kita nato na natay mga low pressure area. So unsa man ni si high pressure o low pressure area? So mo ni siya sa high pressure area, this area or region has ang hangin diri is sinking. So from the upper level of the atmosphere, it will sink padung sa ubos. So dry na siya na hangin, and this high pressure area indicates sunny or clear sky. Ang low pressure area, ito atong nakita sa may tropics, so sa ato ang tabit sa atong country. So this one, ang air diri is rising. So ang warm water musaka yung bugnaw, then those warm and moist air mo to yung porma og clouds, then mo tong makapadala og ulan sa ubos. Another illustration is this one. So notice here, this is how high pressure area behaves with respect to its wind. So kani siya sinking, gikan sa taas, munaog, then pag abot sa ubos is mo scatter. Opposite sa low pressure area, which is mutapok sa tunga at low pressure area, then musaka siya. So kana, so meaning katong moist diri na hangin or ang moisture sa ubos yan dalon sa taas. So ito yung porma og clouds. So let's proceed. So here is an illustration showing you different layers of the atmosphere. So first, we have the troposphere. I think this is around 0 to around 20 kilometers or 16 kilometers above. So this is where weather forms, and most commercial jet or plane travels here. So diri na porma itong mga weather, itong mga clouds, itong mga rain-bearing clouds. So diri na siya mapurma sa ato ang troposphere. Then next we have the stratosphere, where the protective ozone layer, diri ozone layer, floats. We all know, or maybe you've heard from the news or other people or friends, that the ozone layer is now depleting, meaning na-doubt na itong protective layer, and makakos na ni siya sa kainit. So I think isa ni sa mga discussions regarding sa climate change. Next we have mesosphere. This is where shooting star blaze. So mo ni ang space debris o kanang mga meteorite begins to burn up. Then the thermosphere, where the temperature rises, so magkataas din magkainit. Then we have the exosphere sa gawas. So diri sa left side sa atong illustration, atong makita, wala ko naka-pointer, sorry guys. So kani muna siya ang temperature natin, pinakabugnaw 90 degrees, then going to 20 degrees. So you notice sa troposphere magkataas is magkabugnaw. So you notice kung namo sa syudad init, pero musaka mo sa bukid, let's say Busay, so di ba bugnaw na dito. So mo na siya ang isa na sa mga rason niya na pagkataas magkabugnaw tungod sa ubos na ang pressure sa taas. So bugnaw na siya sa taas. So mo nang bugnaw gid sila compare sa city. So next we'll be discussing about water cycle. This cycle of water in our environment or in the atmosphere and in the lithosphere, this will help us understand na kanang mga pag-ulan or kanatong weather. So first, so this is a cycle, no? So wala sa start, so cycle man siya. So maybe let's just start for the sake of discussion sa surface. So evaporation, let's say kaning tubig sa ubos, let's say sa river, sa atong yuta mo evaporate tungod sa kainit, then pag abot sa taas, mo condense, mahimong clouds, then muulan na po, then mag-cycle siya. So kadi siya ano siya more detailed illustration of the water cycle. So aside from evaporation, we have also sublimation. So kanang solid ice mo diretso og ka mahimo siyang gas form sa vapor. So sublimation. So we have also transpiration. This is somewhat like evaporation, but kanilang kay gikan sa tanong from its leaves, then somehow mo evaporate yapon siya. So ang gitawag nila na is evapotranspiration or transpiration. So I think ano na siya further ano na siya illustration atong ganina nga water cycle. So after evaporation, mag-condense or mag-clouds, then sa atong case is ulan, or in other countries ang general term ng ulan nato is precipitation. So precipitation could either be snow, hail, or ulan, rain. So kining sunod is katuning medyo simplified na po siya na format ng water cycle. So murag ani ra gid siya ato ang makita sa water cycle, from liquid mahimong gas, then gas mahimong clouds, nya mahimo na pud siya og liquid, and so on. Wala na siya ang katong water cycle. Basically ani ra gid siya ka And yan yung basic. So this will help us understand the weather. So next, let me give you a short background about how a forecaster make a weather forecast. So first, observation of weather data. So there is, kung itong ipang-mention kanina na meteorological elements, we have temperature, pressure, sa pa to, katong humidity, and so on. So sila gina-observe na siya through gina-measure and observe through instruments and visual observation sa different nato na mga observation stations or synoptic stations. So this is the locations of synoptic stations or observation network nato sa all throughout sa country. So nakakatag na siya. Those stations will measure different weather variables. So we'll discuss at na isa-isa niya. So mo ang gina-measure nato sa mga stations. We have temperature, relative humidity, rainfall, wind speed, wind direction, or basically wind, the atmospheric pressure, solar radiation, visibility, and clouds. So temperature, mo sa measure sa initon. So natay instrument shelter, dito na to ginabutang atong mga thermometers. So dito gina-measure ang mga ang temperature nato from day-to-day basis. From hourly hourly basis, ang uban 3 hourly, ang uban 6 hourly basis na measuring of temperature. So next we have the relative humidity. So is the ratio of air's water vapor content to its capacity. So this element will show us how humid or how many water content in a given in our atmosphere. So will define that one. So meaning kung mas moist siya, may tendency na kanang moisture sa surface madala sa taas, then form cloud. So that's basically how cloud forms. So ang moisture sa ubos dalon sa taas, then mo condense. And sa instrument na gamit ani is the psychrometer. It's a relative humidity by measuring the dry and wet bulb temperature. Basically, this is just a thermometer. Special lang siya. Special. Next, we have the rainfall. So rainfall is being measured through this 8-inch rain gauge. So kung ano na siya, single point, meaning di niya ma-measure ang tibok, let's say, probinsya sa Cebu, but this will represent the said region or province. Kaya dira masalod ang kanang ulan, so na tayo mga conversions ani with respect to area. So mabana-bana na to ang pila jud ang ulan, ang giulan sa usa ka lugar. Do na jud siya medyo error kay point ra man ni siya, point measuring ra man ni siya. So next we have tipping bucket sa DI. Also used for measuring rainfall. Next, we have the wind speed and direction. It's the rate at which the air is moving past a stationary observer. So natay ni measuring device gamit ani or measure ani wind speed and wind direction. So we have this anemometer, the wind dial, and wind graph. So kani sila ga-measure sa direction and sa speed. So importante ni siya labi na sa katong naibagyo, makita nato kung sa kusog atong actual na hangin. So para maka-warn ta, especially dito sa mga manlalayag na to, mga isda or mga shipping vessels. Siya importante. So next, we have the atmospheric pressure. This is the force exerted by the weight of the air. So magkataas ka, matuka sa bukid. So meaning ang column of air or kanang murag, let's say, tubo sa air above sa imo is gamay na lang gaan. So meaning sa taas is low pressure. So in case sa surface, kung napay low pressure, that will indicate as rainy or cloudy. If kanang medyo init or hayag atong langit like blue sky gyud, mostly that would indicate high pressure. So the standard pressure is 113.25. So below that, mostly may matawag nato siya low pressure and taas ana is high pressure. So na to ang standard sea level pressure. So we use aneroid barometer. Kani mercurial, murag wala na niya itong gigamit. Gina-phase out na ni siya kay I think tungod sa mercury content niya. So, hazardous na siya. So we're using aneroid barometer. Altimeter also, this measures usually kanang mga altimeter kanang measure og altitude or elevation. That is just that is derived from a barometer that measures pressure. So next, we have the solar radiation. So this measures the intensity na atong nadawat sa usa ka adlaw. So natay kanang see notice here, this radiation recorder. So natay mo nagkuan diri bulang kristal. Ya, kaning atong makita diri sa ubos, kaning warag papel is kuan na siya, masunog na siya. So indicate na if although masunog atong ana meaning all day nag-init siya. So if naay mga area diyan na di masunog meaning na period na cloudy siya or ni ulan. So mo ni siya ang pag-measure sa solar radiation. Kaya also this pyranometer po measure sa solar radiation. So next we have the visibility. So meaning kung magpag meaning ana mag low visibility ka. So kani siya gina-measure ni siya visually. Dili measure but gina-observe visually. So subjective ang judgment. Pero tingnan na sila yung mga estimation kung sa kalayo ang visibility. Para ilan na gisukod sa una din karon estimation na lang. Then we have the clouds. Kani siya ang clouds is also being observed sa atong mga synoptic station. Kay this would tell us would kanang labi na kaning cumulonimbus clouds. So kaning mo ni ang thunderstorm clouds nato. Mo ni gitang pinaka isa sa mga bantayan na nato na clouds. So importante nato na ma-identify nato ang clouds nato makita. So there are different types of clouds. So kana kung mag-observer ka, I think you need or even forecaster also will need to learn how to identify clouds. So ang gina-observe dira sa atong stations, we have the type of clouds, the amount of clouds kung unsa kadagan ng clouds nato makita sa taas. So natay procedure na sa pag-identify ani. Then also we have the height of cloud. So height of cloud, so ano na po din siya estimation. Height of cloud, so natay ko ani standard naka set up for this one. So again, subjective judgment for this one. Also sa atong synoptic station, we have this kaning upper air balloon nilang gitawag, weather balloon. So this observation is called upper air sounding. So this measures various meteorological elements or parameters sa taas sa atmosphere kay di naman ta ka-measure sa taas. So we are using kaning gigunitan ni ma'am diri. This is a device used to measure different meteorological elements or parameters such as humidity, pressure, temperature na atong pang-discuss ganina. So pagbuhian na, this is I think hydrogen gas ni siya dire. So very gaan gini siya, so lupad gini siya buhian. So this one will go up to the I think sa stratosphere. Amot dito. So every level sa atmosphere yang na certain level na iyang measurean og different parameters. So muna siyang ginagamit nato pagkuha sa taas. Kay dili man enough if surface ra atong tanawon. So we need also data sa atong upper atmosphere. So kana ang signal diri ginasend na siya sa atong mga satellite or radio diri sa atong mga stations. So I think not all stations have this one. Kay mahal gini siya. I think one palupad ani is around 25, I think 25K. So ano siya ka expensive. So I think ang naimay ani ito ng mga dool sa airport. So next after na to naka-measure, so we need to collect and transmit the data dito sa atong mga data centers. So sila gagather dito. Then kung ana ilan na i-analyze ang data, ilan na i-plot sa atong mga maps. Itong ganina to atong nakita kanina na map, itong akong gipakita na pressure map. So those are one of the charts where they plot the data para sa analysis later. So after that, mag-analyze natin sa mga map, satellite, radar images, and other meteorological information available. Then after that, dito na mag-formulate of forecast. So there will be discussions or depende sa forecaster sa yung skill. So that one. So let's proceed. So factors affecting Philippine climate. Sa Visayas, we are greatly affected by the geography. So geographical location, ang forma sa atong lupa, the topography. Then we have the LPAs and HPAs. So ako mention ni kanina na mostly sa tropics nagita yung mga low pressure area daghan. And mostly HPA na sa layo-layo na diri ang center, but na time na maapektuhan ta sa iyahang kadako sa high pressure area. So that one also. Then we have this southwest monsoon. This one. Southwest meaning coming from this area here. Mas Indian Ocean. Padulong sa Pinas. Then we have northeast monsoon. So gikan dili China mo ano, curve padung ana northeast monsoon. So ano siya. So we'll discuss this one later sa further detail. Easterlies also. So easterlies hangin nagikan sa east. So that's what we call easterlies. Then we have the ITCZ and frontal system. So ITCZ stands for Intertropical Convergence Zone. So later we'll discuss this one also. Then next, we have the tropical cyclones or sato bagyo storm, or how do we call it one, bagyo. Then we have also ENSO. So sa ato diri sa Pinas, we know this one as the El Nino or the La Nina events. So first, kani ato ang discuss about the kaning effects sa topography or kanang sa geographic location. So this one, di ba ganina ko na ipakita na ang moist air will evaporate padulong sa upper atmosphere ng mga clouds. This one also will help lift the moist air sa ubos. So dili jud kailangan evaporate. Pwede ra hangin makatabang ni ang bukid o alsa sa kanang moist air padung sa upper atmosphere to form clouds. So you notice here at the windward side, so this one windward ni siya kanang asa moagi ang hangin. So kung nakay moist nakay dagat dira or kanang sapa ba or something moist or basa nga lugar, if natay hangin gikan diri diri, let's say diri sa left padung sa bukid, so motabang na siya og ang bukid motabang og lift sa hangin then form clouds. Sa other side sa bukid wala tayo makita na clouds, so clear sky gid diri. So meaning kaning bukid are one of the factors na maka-affect sa atuang weather and climate also. So we call this one orographic lifting, and this one ang ulan dire is what we call orographic precipitation. So precipitation meaning katong mga hydrometeors na gihulog, let's say ulan na lang. Ulan caused by orographic lifting. So ano siya? So next, natay kaning northeast monsoon or amihan. So kani siya gikan ni siya sa may mainland China, gikan diri mo ana mo curve, then may mo siyang northeast. So meaning northeast coming from the northeast sa atong nasod. So this amihan comes with cold weather, drizzle, and strong winds. Pero nato siya naka-accompany na other system kaning tail end ng cold front or tail end sa frontal system. So kaning weather system, this is the meeting place of the cold air, cold and dry gikan diri kay dry beginning diri lapit sa China, and the moist air na gikan diri. So bangga na sa dira, then this area here will Porma diri ang mga clouds. So say makapaulan ni siya sa bit diri dapit to. Sinotis na tay gi-label dira na ulan-ulan. Usually ang kaning tail end mo ni ang ulan diri and at the kaning naigugid sa amihan is clear sky. So mostly ang ulan ali na diri sa mga shear lines. So, isa ni sa mga weather system na makapaulan sa ato ang lugar. Next, we have the southwest monsoon. So again, this is coming from the Indian Ocean or there is a southwest na side. Doon sa nas. Kani siya is different from amihan. Amihan is cold and dry. Gikan sa China. So diri wala kayo tubig diri. So maana na siya. So meaning ang iyang weather gid mahatag diri sa taas is dry or init. I mean dry or clear sky. Pero ang southwest monsoon is different from amihan. Southwest monsoon gadala ni siya og moist air. So kanang moist air gadala na tayo kung moist ganing air na tendency ta ko ang chance sa maporma ang mga rain bearing clouds. So sinotice ang kanang west side sa atong country is ulangon gina siya during southwest monsoon. Also we have tropical cyclones. So kani bagyo. These are huge wind and cloud circulation towards a single lower pressure area. So ang bagyo nato is a low pressure system. Low pressure din siya. So katong mga LPA na itong gimension kanina, eventually mo develop na siya kung sakto ang environment o yun siya ha. Then those low pressure areas will develop into a tropical cyclone. So tropical cyclone comes with strong winds and heavy rains. Kanang huge waves kuna na siya kanang after effect na sa atong strong winds. So we'll discuss this one later sa atong meteorological hazards. Intro pa ni guys ha. So this one the ridge of the high pressure area. So muna giingon nga ang high pressure na sa layo pero iyang extension kaning gitawag na ridge would reach sa atong nasa especially dito sa Luzon. Also we have easterlies. These are winds coming from the east, mostly from the east. And we have also the intertropical convergence zone o ITCZ. So kani mo ni ang kanang mag-meet ang atong hangin gikan sa southeast sa southern hemisphere ug ang northeast sa northern hemisphere. So kanang mag-meet na sila, mugporma na og clouds and usually ITCZ is the breeding grounds sa atong mga low pressure area ug mga bagyo. So again, later ato ni discuss further. So next we have this ENSO or the El Nino Southern Oscillation. So diri sa tuwa known ni siya as the El Nino or La Nina. So for normal condition kanang normal lang walay El Nino walay La Nina. Muna ito ang condition. So kani ang sa America na side, South America, ilang tubig dito normally is bugnaw. Sa tuwa is very warm. During El Nino, mabali siya ang warm, mabalin diri. Sa tuwa ang cold. Meaning kung mo-cold diri, di ba, kabalo man if warm waters dagan moisture may evaporate, so dagan ulan. Kung bugnaw gani less ang ulan mo nang kung during El Nino dry gid ta kay makasinati taog kanang cooler water, so lesser ang evaporation, then resulting to lesser rainfall sad. Sa La Nina lahi ni siya. Murag amplified atuang or na exage ang atuang normal condition. Ang warm water nato mas moinit pa kayo causing more rainfall occurrences. And most likely po ang kuan ani ang daghan occurrence sa bagyo during La Nina kay daghan porma diri tapit sa tuang nasod dol sa tuwa tungod sa warm waters. So we'll discuss again this one later. So let's proceed with the hydrometeorological hazards affecting the country. Ang pinaka-common sa tanan ang thunderstorm. So kani localized thunderstorms kani siya kapalit di sa isa ka cumulonimbus clouds o CB clouds. Muni kanang baga kay na itom na kay na clouds, kanang clouds kung itom na siya dili pasabot itom na siya kay itom giyang color kuno na siya lack of light munang mo dark siya meaning baga kayo ang clouds then sa base sa kaning base dire is dark na siya kay wala na kay light maabot wala na light ma-reflect bagi ka sa sun munang ang dag-om Kanang kami anak baga na siya na clouds. So kani siya ang thunderstorm accompanied with heavy rainfall, tornado, hail, and gusty winds. So kani siya frequent ni siya sa May to September, but all throughout the year nagid ni siya occurrence ang thunderstorm. So mas dagan ang siya during this period, May to September. So how does thunderstorm develop? So basically ang digit niya is moisture ang kanang unstable air and lift. So kung na moist kini yung lugar diri, yan nakay-init, so dagan mas kusog evaporation niya. So dito siya mo develop na siya, mo himo siyang towering cumulus kani mo taas until himo siyang mature na cumulonimbus clouds. So after ana, if kanang bugat na siya ang iyang taas, so tendency na is mag-precipitate na siya, umulan na siya. So tendency po sa mga severe thunderstorms, ang dagko jud kayo is dili na mapas utong mo tong mga ice crystals na naporma sa taas, mo tong magka-hail. And also kung severe thunderstorm, na po tendency na magka-tornado. So let's discuss kanang mga hazard na naapil ning thunderstorm. So first, we have the heavy rainfall. So sahay kanang thunderstorm is, di ba, towering clouds to siya. So expect kita bundak na ulan. So excessive rains can produce flash floods, which can change small creeks into raging floodwaters, sweeping over structures along its path. So natay mga case dundong mga tong recent lang sa may Katmon ba to? Now, sa natay severe thunderstorms. So pag ulan ato, bundak itong ulan, then sudden din ang pag-rush sa tubig ito sa suba o sa falls. So isa na sa mga hazards sa kuan ha, thunderstorm. So next we have the tornado. Kani murag less raw ang occurrence sa Pilipinas, pero naagi siya occurrence. So tornado usually forms and kanang severe ang thunderstorms. So I think we need to discuss this one sa next na to ng mga na lang webinars kay medyo taas-taas ng tornado na topic. I think ang total diri is ang tornado mostly will form sa mga severe thunderstorms. So kanang kusog na updraft, kusog na saka sa moist air, tendency na is maka-form na siya og tornado. So usually kaning tornado is kusog ni siya. Ambot og 450 kilometers per hour. Do gamay sa area pero kani iyang hangin to sa tunga niya 450 kilometers per hour. So kusog-kusog pa ni sa mga bagyo nato na monitor. Do gamay ra gid siya og kuan man area compared sa mga atong bagyo na bina-refer. So mo ni mga usually damage sa tornado, mga bali natong mga pananom and mga damages sa balay. So this is from Pakangan, Valencia City. So August 9, 2010. Also kani po natay mga na-damage na lugar sa Valencia. So guba ng mga balay and mga pagbaha. So kung isa kanang severe thunderstorms na ay gadalaog kanang napoy tornado and heavy rainfall. So this one di naman play good. So kini dito siya mo play man itong video. So when this is a thunderstorm, nakita na to sa dagat. So we call this one water spout. Isa na sa dagat tornado. So kini siya. So delikado po ni siya. Nagnakad sa duol sa tornado. Isa na sa mga hazard sa thunderstorms. Another hazard sa thunderstorm is ang hail. So kaning hail is normally sa severe gyapon ni sa metabo, severe thunderstorms nang bagga kay na clouds or supercell or kanang daghan bitaw kay thunderstorms sa usa ka lugar na natapok. So tendency na kani hailstorm. So tendency na ang dili kapas og tunaw atong atmosphere sa ice crystals na naporma kung sa kabaga niya, then mo na ang iyang result. Ice crystals ang mahulog. And lastly, ang lightning. So kaning lightning, siyempre thunderstorm atong clouds. Sa pangalan pa ng thunder na gina siya ay lightning. So sino the development of a large cumulonimbus cloud natay mga charge na maporma. So kanang charge basta dagko na kay na supercharge na kay siya is will result to lightning. So natay cloud to cloud na lightning, natay cloud to ground, and other og lightning pod within the cumulonimbus cloud. So kaniya safety precautions kung natay lightning sa una katong dumduman akong bata pa ko is pag nay lightning maligo may ulan noon, so dapat dili ta inana kay nanay mga case na nakilatan gyud diri sa atong lugar diri sa Cebu province. So kung nay lightning makadugog na magdugdog ayaw jud mo pensa og gawas-gawas. So go inside the house made of non-combustible material or large building. Avoid using electrical appliances kung mahimo. Tagalon nato kay what if mo abot sa tuwang transmission line o sa linya nato sa frente. So posible pud siya makaguba sa mga appliances. Kung nasa ka sa gawas, then ayaw pagyud pagpaduol sa kanang nakalaim ito nakahoy sa dangerous siya. Kay tendensya na dakpo na sa thunderstorm ang kanang naka-low na naka-isolate nga kahoy. Labi na taas na kahoy, so palayo gid man na. O kani pod palayo pod sa tubig. And kung natrapid ka sa field, open field, so tendensya na ang lightning is stuck po niya ang pinakataas na pinakadool niya na maigo. So meaning ikaw ang pinakataas na lugar, walay kahoy, walay building. Tendensya mo ni ang natay siya gi-suggest diri na do not lie flat on the ground. Natay ka ni, natay recommended action ani. Kani oh. So nani mo atod kung nakasa ka ng open field. So this position to basahan ni. This position looks hard but this could save your life. Because with your heels together, if lightning hits the ground, it goes through the closest foot up to your heel. So meaning mura na siya og mo labay sa imong tiil. Instead of ato sa imong organs sa imong lawas. Right? So next, dito sa tropical cyclone oras. Malayo pa. The tropical cyclone and its associated hazards. So tropical cyclone, so weather disturbance with low pressure areas ito nga characterized by very strong winds blowing counterclockwise. So ang atong bagyo diri sa northern hemisphere, so kaning sa ato ang area sa northern hemisphere, ang bagyo nato diri is always counterclockwise. Heavy rainfall og tornadoes nasa ani na kaning tropical cyclone. Kaning tropical cyclone nasa di siya gidala ng mga cumulonimbus clouds. So based sa kaning World Risk Report sa 2017, I don't know if na by updated ani, we're the third most exposed risk country sa natural hazard. The 20 tropical cyclones in a year, 5 of which are destructive. So natay mga one paper showing na due to global warming daw nanay mga intense tropical cyclone. I think we need another webinar for climate change or global warming. Medyo kulang na tong oras kung mapila to sa atong session karon. Good if natay ma-separate na day para ng climate change. So again, this is the tropical cyclone forecast areas of PAG-ASA of the Philippines. So this siguro kadugod naman ng Philippine Area Responsibility. So that is not used for political purposes. That is used for meteorological purposes. So sana diha ang mag-monitor mga bagyo. Aside from the Philippine Area Responsibility kaning dash na gray, we have also other domains. So we have the Tropical Cyclone Advisory Domain, kaning pula. And we have the Tropical Cyclone Information Domain, so kaning yellow. Kinsa kay na-idea kinsay makatubag aning anong paana atong bagyo, paana ato ang area na of responsibility pa daghan diri. Mas daghan diri. Mas focus sa kilid Can anyone has an idea? Anong guys? Wala mo volunteer?
Volunteer ko.
Sige.
So, ang area of responsibility na sa Philippines kay dinha usually gikan ang storm niya kang padung siya sa Pacific Ocean, mga breeding ground sa mga cyclone.
Oh, tama to si Philip D. Tama to siya yung ingon. So, ang ato ang domains is most likely in mas takog area diri sa kilid kay usually atong bagyo is diri mapurma. No, tama to yung gingon. So this forecast areas or these domains are different sa atong EEC na to ha, atong economic zone. So atong economic zone is diri to dapit ata, mag 300 nautical miles. So kani tama to yung ni Philip na kanang pakuha ni siya mas takog area diri sa kilid kay para ma-monitor dayon nato ang mga mapurma na bagyo. So layo pa daan, ma-check na nato, monitor na nato, uy, may bagyo, mag-andam na ta. So mo na trabaho sa PAG-ASA. Tama. Right. So let's proceed. I think more sa ganina. So mo ang mga bounded regions sa ato ang different domains. So next, ano yung mga accompanied hazards sa katong ato ang tropical cyclone? Number 1 gid ani is ang kusog na hangin. So layo pa ang bagyo, pwede na tayo makasinati og mga kusog na hangin. So ang ulan mostly, ang ulan sa bagyo is lagi na sa duol siya ha. Pero kaning hangin is bisag layo pa makabati na ta og kusog na hangin. So maximum wind speed sa wait nga. Ano? Usually katong atong si Yolanda ba to, sinabot siya more than 220 kilometers per hour. So ito na hangin doon sa tunga niya. Then the next hazard is the heavy rain. So again, so na siya mga cumulonimbus clouds around sa bagyo na to. So munang nasa heavy rainfall sa. So munang two main hazards sa to ang tropical cyclone o bagyo. So kani ato ni play be. Saan ko play? Yan. Suga eh. So sample ni siya sa usog na hangin. So ito na yung next, no? Sila na, hangin kayo. Oops. So mato ang katong strong winds. So ang pag-ulan sad saybot ang bagyo dili mo agi sa tuang kayutaan pero sa hay mapakusog niya ang atuang southwest monsoon, and once southwest monsoon is enhanced, makapadala na siya og daghang moisture, and again more moisture is means na more chances of rainfall. So magpaulan sa kusog sa asang bayan sa itong nasod. Okay. So sa dili siya moagi atong bagyo, na tendency na mabira niya ning hangin kaning warm and moist air mass diri sa southwest. So next we have storm surge. So katong sa Yolanda, I think ang wala na expect ato sa mga tao is ang storm surge. So karon ato ni i-apply sa storm hazard. This is the normal rise of sea level causing big waves at the coast. Sa tropical cyclone approaches and hit land or made landfall. So kaning storm surge is caused by kanang kusog na hangin doon sa center sa tuwang bagyo. So muna isa sa mga kakos sa sudden pagdako sa tubig. And also ang katong low pressure area, katong tunga niya sa low pressure man no. So tendency to is murag muburot ang tubig dito dapit together with the wind. So mas mudako gid ang balod caused by tropical cyclone. So again kaniyo, lawan natin ha. This is from Typhoon Karen and Typhoon Yolanda. So kani sa Yolanda ni siya. Yun. Ana ang natabo sa Yolanda. Okay na. Even na strong siya na bagyo. And I think dagan unaware sa storm surge at the time. That's why education is important. Kani mas pagbalutan kita sa hazard dala ni mga hydrometeorological hazards. Ano so kinabalod. Kalit lang na wala siya dagkong nga tubig. So last slide and mud flow also hazard po ni pero kan na ni siya indirect effect na ni sa bagyo. This is caused by heavy rainfall na siya or continuous rainfall for pila ka days. So that would definitely be the case. So napunitabuan ni sa Mindanao sa una way back 2011 Sendong. Also that one. Mad gikan sa kanang bukid. So classification of tropical cyclones in the Philippines. First, we have the tropical depression. So from low pressure area, ang next yan na level ana is tropical depression. So nasa maximum winds up to 61 kilometers per hour. So next, we have tropical storm. So kung mukusog pagid siya, so that's why usually ato nang ginaingon na, uy, ang atong bagyo is nag-intensify pa. So ito tropical storm. So next na category, stronger category is the severe tropical storm with 89 to 117 kilometers per hour na hangin na near sa tunga. Then next we have the typhoon. And lastly we have the super typhoon. So si Yolanda na bilong diri sa super typhoon category. So kani atong mga tropical cyclone wind signals na gina-issue na to sa atong public. So number 1 again, this means na ay around 30 to 60 kilometers per hour na hangin within the 36 hours. So it's either happening na or padulong pa. So that's manay pasabot aning kining part. So same goes with 2, 3, 4, and 5. So still number 2 within 24 hours or maybe happening na makasinati or we'll be expecting 61 to 120 kilometers per hour na wind. So kani nanatay light to moderate damage. Number 3, 4, and so on 5. Usually number 3 is I think kung ano siya na category typhoon. So severe tropical storm, 2 typhoon. Then 4 is I think typhoon. Then this one 5 is super typhoon. So yung normal natin yung mga executive order, I think this is mga sa ano na ni implementation na ni automatic. So sa una pa ni siya way back 2012. I don't know if there's an updated executive order. But normally pag natay win signal number 1, matic preschool wala na. Number 2, preschool, elementary and secondary levels. For 3, all levels, graduate school, o ang mga government offices wala na sa nito pa. So ang private is depende na sa tag-iya sa kampanya kung sa iyang jurisdiction or sa iyang plano. Sa iyang sakop. So section 2, kanisad without basta wala pa tropical wind signal on that place na ay we power ang local government LGU2 to cancel or suspend class or work. So na with coordination with PAG-ASA and DRRMC. So this one is the climatological records tropical cyclones na mahagi sa ato ang nasud. So sa October ting 2 or 3 and I think na tayo tulo ata nilabay na to duha ang nilabay ang isa kay igo ra gid ning sod niya na dissolve. Then November will be expecting again 2 or 3. Then December gamay-gamay na lagi siya. So if you notice here this graph here di na siya maklaro no. Klaro ba? So we have January, February up to December. As you notice our typhoon season is at kaning tulo ka graph diri July up to September. So daghan tay bagyo dira. But normally those periods ang bagyo nato is asa man na siya? July kani. Normally Luzon siya na part ang mga agi. Kaniya dili ni siya yung na landfalling gyud kanang muagi sa yuta. It's either ning sulod sa par yan ikaw sa rabod na wala ka landfall. Pwede man inana. So normally ang typhoon season nato is during July to September. Pero mostly ang yang track nato kita sa sunod slide. Usually ang track niya is nasa taas dapit sa Luzon. And normally sa Visayas ang atag yung normal takog chance is during the months of October, November and December. Based siya sa climatological records. So based sa mga atong natala na atong ginaihap na bagyo na nangagi sa diri sa Visayas. So kasi sendong sinotis o Mindanao siya niagi. So sa atong climatological records sad is mostly pag December na sa Mindanao to Visayas iyang track. Pablo also December sad to. Then Yolanda and Ruby. So muna siya. During this period ari ni siya maagi sa Mindanao o Visayas. So sa atong website sa PAG-ASA we have dito nakalista akong mga names that we'll be using sa pag-name sa mga bagyo. So I think atong next bagyo will be Odette. So mag-name na ta og bagyo, a local name if mosulod sa tuang Philippine Area of Responsibility. So I think ang nanulod karon is Lani, Maring and Nando. And the next typhoon will be named Odette. So nabud tay gina-retire nga ngalan sa bagyo. So ang kriteria ana is kani criteria for retirement is 300 or more ang patay caused by that cyclone or bagyo and around 1 billion or more damage to agriculture and infrastructure. So retire gani di na siya pwede gamiton. So for example si Ambo 2020 ni kani nakadamage siya og 1.57 4 billion. So ato na siya gina-retire. So sa listahan ganina at gipulian to siya as aghon. And to also with this tropical cyclones Quinta, Rolly and Ulysses. So kung gipamulian na siya og kaning mga pangalan. So the next hydrometeorological hazard is the frontal system. So kung mo yung ipakita kanina nakatong kunay amihan, company gina siya with a frontal system. Also, kung ano yung tawag nila ni tail end sa frontal system or shear line. So kini siya characterized by largely by increased cloudiness and heavy rains. So normally November to February siya sabay ni siya sa atong amihan normally. So usually ang apektuhan ani is ang eastern part, so dili lapit sa kilid sa kung tanong sa mapa sa may tuo lapit, so sa east side sa atong country. So ang impact ani na system nato or katong tail end or shear line is heavy rain, continuous rains. So kana will cause also landslides, so baha. So kana sana sa mga factors sa frontal system. So next we have the ITCZ. So as I mentioned earlier, this is a series of low pressure areas. So diri nag-converge or nagtagbo ang atong hangin from the southern hemisphere. So we call that the southeasterly gikan diri, and the northeasterly winds. So we call this one in general trade winds. So kung tagbo na sila, tendensya na is adunay series of cloud clusters. Cloud clusters will indicates low pressure area. So ang low pressure area usually kani ang breeding ground sa tuwang bagyo. So normally katong for the past weeks ato nakita kung magtanawan mo mga news, active ato ang ITCZ, and also we noticed there are a lot of low pressure areas ug ulan-ulan sad for the past weeks. Active ato ang ITCZ, then nabot tayo ng mga naporma na bagyo within the ITCZ. So again, hazard ani niya is nani siya mga thunderstorms, so nani mga heavy rains, mga flash flood and flooding, widespread thunderstorms, breeding ground of tropical cyclones. Yeah, it also lays over the Philippines during the month of May, October. So sayo ang concentration sa ITCZ is nasa Luzon, Visayas, or even sa kung dako kayo, all over the country siya maka-affect. And we have the monsoon. So we have the southwest monsoon, and the habagat or the amihan or the northeast monsoon. So among those two, ang southwest monsoon may grabe ka magpaulan. Especially dito sa eastern side sa country. So it's normally southwest during June and October. So any kung natay bagyo mo agi and nasa tay habagat, usually mainas ang habagat mo na yung makakos sa mga ulan-ulan. Nakusog, then makapabaha siya. Also, then next we have the northeast monsoon. So kani siya kuyog din siya sa may amihan, and normally kani northeast monsoon will bring us fair weather diri sa taas. So hayag ni siya, but there is na part which will cause the formation of shear line or the tail end of the frontal system. Makapaulan po ni siya diri sa mga eastern sections sa country. So normally occurs November to February. So kuyog din siya sa frontal system. So summary, most natural disasters are related to hydrometeorological hazards. So increasing frequency, intensity of extreme events. Hydrometeorological hazard pose significant threat to all areas in the Philippines. Physical disruption to infrastructure, human health effects, significant economic losses, and loss of lives. So with the past events, tayo dapat i-review sa itong mga building codes. I think we need to retrofit or redesign itong mga building na makastanan ng mga meteorological hazard. Then strict implementation of land use zoning to restrict development in identified high-risk areas. So isa gini sa mga tantipod. So itong mga high-risk na lugar, sa mga low-lying areas, nung ubos sa bukid or doon sa sapa. So dapat gina-check ginag-ayo before mag-urbanize din ang lugar. Okay, makakos na og disaster. So next, we have this public information and warning system na ginapagawa sa PAG-ASA. So again, ang trabaho sa PAG-ASA is to inform public about these hydrometeorological hazards. So we have the public weather forecast. So kani mo itong common na ni siya every day, twice a day din siya ginabuhat. Then we have the El Nino and La Nina monitoring advisories. Weather advisory, tropical cyclone bulletin, gale warning, rainfall warning, thunderstorm warning. So ito ni siya sahod. Sana to. So kani atong 24-hour public weather forecast. So kani ato ni makita sa atong website and also sa atong social media official social media accounts sa PAG-ASA. So diri makita na rato ang synopsis, meaning ang atong current state, status or sa nga system ang ga-affect karon. So ano siya. So ang forecast is na diri sa ubos. Makita diri ang mga lugar, then unsa yung weather condition, unsa yung cause niya, and ang mga possible impact. So kani siya dili nato ni ginabuhat. May bagyo man o wala. Next, we have the El Nino and La Nina monitoring. So kani dili nato makita if nabata sa La Nina alert or padulong ba La Nina or dili. So this is the recent na El Nino La Nina monitoring sa PAG-ASA karon. So right now we are on alert level. So ito nakita na natin for the next 3 months, including this month, October, adunay chance na mag-La Nina na ta. So as what I discussed earlier, we have warmer waters here, cooler waters in the Central Pacific. So muna siya ang El Nino La Nina monitoring. So nasa tayo naka-PDF ani, so naka-word ni siya. So diri mas detail ni siya na advisory. Kita diri ang content sige nakita sa atong mga climatologists sa regarding sa ilang nakita sa ENSO or La Nina. So next we have weather advisory. So kung kini siya gina-issue ni siya if natay weather system na nag-prevail and kanang system gahatag og hazard. For example, southwest monsoon. So what I discussed earlier, southwest monsoon will bring rainfall sa atong nasod, especially dito sa western side sa country. Usually gina-issue ni siya if may makita na kusog na pag-ulan or natay ma-forecast na possible continuous rainfall. So kana gina-issue nato ning weather advisory. Then we have the tropical cyclone bulletin. So kani gina-issue ni siya if ang bagyo nato naa na sa tuang Philippine Area of Responsibility. Gina-issue ni siya every 6 hours. Then if ang bagyo na to is about to landfall, every 3 hours na siya gina-issue. So sa tropical cyclone bulletin makita mo dito ang ato ang forecast track o atong yang observed track. O ang katong mga lugar na naka tropical cyclone wind signal. So again, kani mo ni siya ang atuang domains of forecast. So natay different products sa atuang tropical cyclone. Mo ni siya kung natay bagyo, automatic natay bagyo sulod sa atuang either sa TCID, sa atuang tropical cyclone information domain, tropical cyclone advisory domain o ang atong PAR, automatic na i-update ang automatic na tropical cyclone update. Kini siya gina-appeal ni sa katong public weather forecast. So ang TCA i-issue rin siya kung naatay ang cyclone na sa ato ang tropical cyclone advisory domain and forecasted na mosulod siya sa ato ang PAR within the next 5 days. So twice daily ni gina-issue. So kung naapoy ang bagyo na nasa atong PAR na natay TCB. If about to landfall 16 nautical miles. So kana every 3 hours na siya. Kuyog ani ang kaning atong tropical cyclone warning for shipping. So kani atong i-visualize be. Ito atong discuss. So kung natay bagyo sa gawas, ang atong i-update wala tay issue na product. Di ato i-update sa ato ang public weather forecast. Once mosulod na mag-update sa tuwang tropical cyclone update. Nanatay tropical cyclone update. Ato ini gina-appeal sa tuwang 24-hour public weather forecast. Nya if kani kung sunod sa PAR nanatay, sunod sa TCA nanatay, ang sunod sa TCA niya dili mo sulod sa next 5 days, TCU ra gyapon nato himuon. And if mosulod sa next 5 days, base siyang forecast, so nanatay, tropical cyclone advisory, issued twice daily. Ito na sa PAR na punta issue na tropical cyclone bulletin o ang tropical cyclone warning for shipping. And about to landfall, every 3 hours na issue ato ang tropical cyclone bulletin. And eventually, kung pagkawas na siya, about to exit na magkuha na rin tana, mag-final bulletin na rin sa tropical cyclone. And lastly, mag-TCU na lang ta kung magawas na gid siya sa ato ang tropical cyclone advisory domain. So okay, na-discuss na kanina tropical cyclone warning signals ato na skip. So gale warning kani kung natay kusog na hangin, for example, southwest monsoon kung prevail, so natay issue na gale warning para ni sa atong mga mandalayag na itong mga mangisda or mga marino. So we're giving warnings also to them tungod sa kaning kusog na hangin which will cause dagko ng mga waves. So dinata sa rainfall warning system or RWS or certain nila ni is nowcasting. So with I think 2 to 4 hours. So that's nowcasting ata. So for nowcasting, we use satellite images and radar images. So muna ito ang workstation for the RWS. So natay kita tanaw ng mga images captured by satellite and our radar. So this is a sample of a satellite image captured by Himawari 8, which we are using, which PAG-ASA is using to check our atmosphere. This one also a satellite image. This is an infrared image. I think mo na yung background kanina sa intro. So that's a satellite image, an infrared image. So this measures the temperature. So kaning pula meaning bugnaw na siya. Meaning bugnaw na sa pinakataas sa atong atmosphere. So meaning possible kani siya is very very high clouds. So kani siya muni kato si bagyo na pag-ura ni gawas, si bagyong Maring. So, di ba baga kayo, yung gatuyok. So, wala siya. This one also, a satellite image with numerical methods nagibutang. So, nani siya gamay na model din nagi-combine with the satellite image. So, product Japanese sa Himawari of Japan. So, this one, radar image. So, natay, for example, ganisa siya sa diri sa Mactan, sa Lapu-Lapu natay radar diri. So this one is a sample of a radar image. So it captures asa ang location sa may dagko na reflectivity. So meaning nasa i-send nga signal nya kung mubanda na meaning anay baga dira na porma sa atmosphere. So posible kanang baga is baga ang clouds or cumulonimbus clouds ana. So mo ni ato ang coverage sa ato ang radar. So tanaw nato sa diri nga side medyo putol na siya kanay dako diri na bukid kanlaon nata Negros. So di na siya kita diri blind na niya. So mostly ang ato makikita ani kay ang Bohol, Cebu and kining Negros. So likod ana sa may diri sa panid niya takitaan. So all throughout sa atong country natay different radars naka-install. So nagkakita si radar dira for again purpose is for RWS or rainfall warning system. Example kani natin nakita na baga diri sa Cebu. So proper siya magpaulan ato na lang gi-warningan ng public na hey guys natay thunderstorm na ato i-expect within the next 2 hours dito sa Cebu. So, nakagamit ang atong radar. So ma-warn atong public, maka-go to safety places pa, and makapahikot pa sa mga labuhanon. So this one, thunderstorm advisory. And if the rainfall will persist, ilabi na og system, so atong issue ana is rainfall advisory. Kami widespread na ulan, sample whole Cebu province or whole Central Visayas. Normally we issue rainfall advisory na. And if persist pagid ang rainfall, ang ulan, then we will issue color-coded heavy rainfall warning. So mo siya, naka-color code na. Usually mo ang maabot sa inyong mga cellphone. So with coordination with NDRRMC, so sila na mag-disseminate ani sa public. So mo siya. So mo siya ang meaning ato, na yellow, na orange and red. So ang yellow ang medyo pinakaubos nila, then red is the pinaka-serious na ni siya na warning. Sa yellow, kaning ulan, 7.5 to 15 mm. Flooding is possible, last is possible. Sa orange, threatening na siya, meaning anytime pwede na magka-flood o landslide. Then the red, kani siya is makita na gid na nanagid possible signs of flooding and landslide. Kanang labi na gid ang ulan. So ato nang expect public kato mga nasa lulayong areas is ato na lagi nang advise to evacuate. So how we disseminate information? So we use social media, radio, TV outlets, and SMS. So muna siya mga forecasters. So we normally disseminate information sa TV, then radio, then SMS. So I think that's all. That's all for this webinar. If you have any questions or clarifications, I think we can ask now.
Okay, thank you so much for the informative and comprehensive presentation, Sir Mark. Your discussion is really essential for our daily lives and how we react to future hydrometeorological hazards. And now, we're already in the open forum. Students, grade 12 season, and also viewers, if any of you have any questions, I'm sure our speaker would be pleased to answer them. You can comment your questions here in Zoom or in our Facebook Live. We have people on standby reading the comments as of the moment. So we've got one question from the audience. So the question is, what is the cause why weather varies from place to place?
Okay, no? Why weather varies from place to place?
Yes, sir. What is the cause why weather varies from place to place?
I think I mentioned it a while ago. There are different reasons why different places varies. So as what I have shown you earlier, so Philippines, just our country alone has different climates. So that is because we are affected with different weather systems. For example, wait, let me go back to my slides. Am I still sharing my? Oh, not anymore. So we are different places has different weather. It's because again, number one is the geographic location. So with those mountains that could affect the weather or climate of different places. Other thing is we have different weather systems affecting on certain periods of the year. For example, southwest monsoon. So that's affecting the country during the months of I think around mid-year. So that's the case. So possible the west side of the country is raining and the east side is does not experience that much rain compared to the west side. So what I want to tell you is that the location and the different systems uh, affects the reason why the different places has different weather.
Okay, thank you, Sir Mark. Next, we have another question from Facebook Live. So, about the hazards of lightning during thunderstorms, how long do you have to stay out of the water after the thunder? So,
I think you need to stay out of the water until the uh, thunderstorm. I think until you can't hear any more thunderstorms, or maybe until the rain stops, just to make sure that thunderstorm is already dissipating. So I think it's not advisable to go out even if you're not anymore hearing the thunder. So as much as possible, stay inside, stay away from water outside, especially kanang ulan pa.
sir, thank you. So, we have another question from our Facebook Live. And so, does typhoons affect geological matters greatly?
Again, ma'am.
Um, does typhoons affect geological matters greatly?
Geological what?
Geological matters, sir.
Affect?
Yes, does
Uh,
typhoons affect
does
geological matters?
meaning what does he mean? Change geological features atong country? Something like that? What? Or does the geography affects typhoon? What? Can you clarify that one, ma'am?
Yes, sir. Geological features.
Normally, if typhoon is uh, not that strong, normally typhoon track intensity is affected by the landmass. So normally, if huge landmass, it would weaken the typhoon since landmass will deprive the typhoon with moisture, and also the friction is greater in land. So yeah, the geographical location or the geography affects the typhoon or any tropical cyclone.
Thank you for that answer, sir. So, We have still a few questions, and here's another one from the comment section. So, are there any human-induced hydrometeorological hazards?
Human induced. I think mga hydrometeorological hazards na discussed earlier was normally natural naman siya mostly. I don't know if there's a human-induced hydrometeorological hazards, but normally natural naman ang development. For example, thunderstorms, and especially bagyo. So those are naturally induced na mga weather systems. I'm not sure if there is any man-made like weather storm device. I'm not sure. I think wala ata. Any more questions?
That's all of the questions, sir. Thank you very much. So we have no more questions. So let us now proceed with the presentation of certificate and tokens. Please welcome Professor Kim Bondo.
Hi. Hi, good afternoon. Can I be heard?
Affirmative, sir.
Okay, thank you. Before I'll present the certificate, may I just address that question a while ago, if there is such a thing as human-induced hydrometeorological hazard. Sir Mark's answer was right. So far, there's none. But then I suppose the one who asked that question, Sir Mark, watched the film Geostorm. Yeah, most likely.
Yes.
So that film was please note that that film is obviously a fiction. Okay. In the near future, I even don't know if that's possible, but really that film is a good one. Okay. Makalingaw siya, entertaining siya.
Possibly. Possibly
Oo.
in the future.
Yeah,
Sa nanonaan, posible.
Okay, so I think Anne, do we still have some more questions? No more? That would be all?
No more, sir. That was all.
Okay, so before I'll present the certificate of appreciation, let me just say some few words. Okay, so since we started having a DRRR class, and I think we started it way back, I think 2012. No, sorry, way back 5 years ago, I think. I never missed visiting to PAG-ASA. Okay, PAG-ASA Visayas to be specific, because our country is part of the so-called typhoon belt. Okay, so it is but proper for us to have this kind of webinar on hydrometeorological hazards and preparedness. No, kaya nga to ang kanang nasod ang atong Pilipinas nya kung asa sad ta located kita Cebu, agianan man ta og bagyo, so kinahanglan ta nga kanang nay awareness no about these things. Now, moreover, PAG-ASA is very accommodating on every request for visit and lecture. However, now that the visit is not allowed because of the COVID-19 pandemic, PAG-ASA warmly accommodate still every request of webinar that my DRRR class would ask from PAG-ASA. And with that, PAG-ASA, I am very, very thankful, as in very, very thankful. My warmest gratitude. And to our speaker for this afternoon, Sir Mark, Engineer Mark. Sir, thank you, good kayo, sir.
You're welcome. You're welcome, sir. Then thank you, sir, sa pag-facilitate sa kaning education kaning webinar, sir. It's also helpful sa mga side na ma-educate po ang mga kabataan regarding sa hazard.
And kuan sad, sir, it's also part of my advocacy as a DRRR instructor nga kanang naagyoy awareness no on this different mga um, hazards ba, natural hazards. And with that, may I request the in charge to please let's present now the certificate for our speaker. Jeremiah or Philip, can we present now the certificate of recognition for our resource speaker? Okay, so while we are waiting for the certificate to be presented on screen, Sir Mark mentioned a while ago, actually it's a very good idea raised by Engineer Mark that maybe one of these days, sir, we will be inviting you again for a webinar on climate change.
Yes, sir.
Um,
It's kanang ko sir, kailangan siya og more time to tackle about climate change.
Oo.
Mabitin ta if we will insert it on this one. I
Yes,
think
sir.
it's good to discuss first katong sa imong email sir regarding the basics of weather. Mao gid una dapat gyud basics of
Mhm.
weather. Then we go to the hydrometeorological hazard. Then later maybe we'll discuss on climate change.
Oo. Kay kuan sad, sir, especially nowadays nga kanang murag kanang pronounced na no ang kanang murag effects ato ang climate change ba, but unfortunately naagihapon tay mga katubitong so-called mga conspiracy theory
Yes,
about climate change. Yeah.
actually karon sir ginadebatehan niya po nila, but I think
Yes.
data shows that there's a out of trend na change sa ato ang, let's say for example temperature. So
Oo.
natay na mas mayog na-separate for that one instead of i-appeal diri sa atong topics karon.
Yes, sir. And I thank you very much for that, sir. So hopefully, if time permits, sa mo ang class, sir, I might be inviting again PAG-ASA for a webinar on climate change. Thank you, sir.
Okay, sir. You're welcome, sir.
So here is now the certificate of recognition, and let me read. University of the Philippines, High School Cebu, um, proudly presents the certificate of recognition to Engineer Mark Geoffray I. for sharing his valuable knowledge as the guest speaker on hydrometeorological hazards during the webinar conducted by the Disaster Readiness and Risk Reduction, or the DRRR class of UP High School Cebu, given this 13th day of October 2021. So it's signed by me as their DRRR advisor. The webinar head is Jeremiah Kizaya Balmori. She's also our student council president, and then by our principal, Dr. Catherine Rodel. And then aside from that, sir, we also have a certificate which we will present. Do we have that, please? We also have actually, sir, a certificate of appreciation, which we would like to give to PAG-ASA. And sir, by the way, sir, this is our token of appreciation to you. We will be printing this, sir, and then we will have it framed and then that owned by anybody from the class personally to PAG-ASA Mactan. So we really hope, sir, that you appreciate our simple token of appreciation to you.
Thank you, sir. Thank you, sir. Ayos kayo.
Thank you. Salamat.
Thank you, sir. Thank you.
Okay, Anne, back to you.
Congratulations and thank you so much, Engineer Gales. We are very delighted to have you here with us today. And now, to formally close this program, allow me to welcome again Professor Kim Bandok for the closing remarks.
Okay, so I think I already have said my closing remark a while ago before I presented the certificate. Sorry for that. But anyway, I would like to extend my sincerest appreciation and thank you to the DRRR class of school year 2021 to 2022, especially to our webinar leaders for their very active engagement, participation, for us to be able to have this series of webinars. So the webinar that we have today, which is on hydrometeorological hazard, is just first of, I think, first of the 7 webinars that we will be having. So there will be more webinars. There will be, I think, 6 webinars more before our semester for DRRR will end. And then this is just the first. So for our next webinars, still the same. We will be live streaming it via Facebook, and hopefully for our second webinar and onward, we could also live stream it to YouTube. Okay, and so with that, I would like to extend my sincerest appreciation and thank you to everyone who attended this webinar, and to the DRRR class of 2021 to 2022. Congratulations and thank you as well. Thank you.
So ladies and gentlemen, we thank you very much for your active participation in our first webinar on disaster readiness and risk reduction, hydrometeorological hazard. Thank you to our speakers, viewers, and organizers. Before anything else, there will be a Google Form link, which also includes an evaluation form, posted in the comment section here in Zoom and Facebook Live. And it will be open for 30 minutes. After you fill up the forms, in approximately 5 minutes, certificates will be emailed to you. Kindly click the link in the comment section and fill up the form so you can receive the certificates. Thank you. Once again, thank you everyone and have a wonderful day ahead.